Hello Year 12 and welcome to Purple Mountain Maths. We are doing the 2025 HSC paper for Mathematics Advanced. This is part 8, question 25 and 26, worth 11 marks. Question 25. Show that the derivative of sin x minus x cos x equals x sin x. Pause here to try it yourself. Okay, so the left-hand side is the first derivative of sin x minus x cos x. So we're going to need to use a product rule on that second term where u equals x, v equals cos x, u dash equals 1, and v dash equals minus sin x. Okay, so the first term, sine, just differentiates to cos, and the next term is the derivative of that product, which is u to v dx plus v to u dx. So it's cos x subtract x times minus sin x plus cos x times 1. So we get cos x plus x sin x minus cos x. The cos x's disappear. We get x sin x, and that is the right-hand side as required. Okay, part B. Hence, find the value of the integral from 0 to 2025 pi of x sin x dx. Okay, so the fact that they have told us hence means we have no choice but to use that result from above. So I'm straight away going to replace the x sin x with the version as above, which was d dx of sin x minus x cos x dx. Okay, so now I can just replace that with sin x minus x cos x from 0 to 2025 pi. So it's sine of 2025 pi minus 2025 pi times cos of 2025 pi, and all of that then subtract sine 0 minus 0 cos 0, and all of that is 0. Okay, so let's think about what we've got. We've just got those first two terms, sine 2025 pi minus 2025 pi times cos of 2025 pi. So let's think about the shape of a sine graph. We know it takes 2 pi to repeat itself, but every multiple of pi it's going to be 0. So taking the sine of any integer multiple of pi is 0. So that helps us realise that that first term is 0. And let's think about cos. So 2 pi is there on cos. Pi is at minus 1. And it's going to be again at minus 1 when we do 3 pi and so on. So an odd number of pi, when you take the cos of it, equals minus 1. So we've got minus 2025 pi, and 2025 is certainly odd, so that is minus 1. So those two negatives will cancel out. We'll get 2025 pi as our answer. Question 25, part C. The regions bounded by the x-axis and the graph of y equals x sin x for positive x are shown. Let an be defined as the integral from n minus 1 pi up to n pi of x sin x dx, where n is a positive integer. It can be shown that the absolute value of a to the n is 2n minus 1 lots of pi, and we're told explicitly do not prove this. Find the exact total area of the regions bounded by the curve y equals x sine x and the x-axis between x equals 0 and x equals 2025 pi. Pause here to try yourself. Okay, so let's use this result and substitute in n equals 1 so we get the idea. So A1, the size of that is 2 times 1 minus 1 lots of pi, 2 minus 1 is 1, equals pi. Similarly, when we consider n2, it's going to be 2 times 2 minus 1 lots of pi, which equals 3 pi. So we can connect that to the graph above, that this area up to pi, that area there, is A1. And this area here, the absolute value, is A2. And here is A3, and here is A4, and so on. So conceptually, there must be an area from 2024 pi up to 2025 pi, and we would call that A2025. Okay. A to the n is 2n minus 1 pi, or if we're particularly interested in A2025, that would be from 2024 pi up to 2025 pi of x sine x dx, and that would equal 2 times 2025 less 1 pi, which is 4049 pi. So the sum of all of those areas is A1 plus A2 plus all the way up to A2025. So it's pi plus 3 pi plus all the way up to 4049 pi. So this is a nice simple arithmetic progression. We've got n equal to 2025, we've got a equal to pi, we've got the common difference of 2 pi, and we know, in fact, that the last term is 4049 pi. So the sum to 2025 equals n over 2, the first term, plus the last term. So I get 4100,625 pi in square units. Question 26. A piece of wire is 100 centimetres long. Some of the wire is used to make a circle of radius r, and the remainder of the wire is used to make an equilateral triangle of side length x. Show that the combined area of the circle and equilateral triangle is given by this expression. Okay, so notice that that expression for area doesn't involve r at all, so we already know that we're going to need to eliminate r. So let's think what we do know. We know that the perimeter of the circle is 2 pi r, and we know that the remainder, which is available for the triangle, is 100 minus 2 pi r, and that equals 3x. Because we have a circle with radius r and we have an equilateral triangle of side x. So let's go ahead and eliminate that r. So 100 minus the 3x equals 2 pi r. R equals 100 minus 3x all over 2 pi. Okay, so the area is the circle plus the triangle. So the area is pi r squared plus the formula for a triangle, half AB sine C. So we've got pi times r squared, which we now have expressed using x, plus a half of x squared times sine of 60 degrees, which is root 3 on 2. So let's rearrange this a little. I've got 100 minus 3x all squared on 4 pi plus a quarter root 3 x squared. I can pull out that quarter and write the terms in a different order in order to get a quarter out the front of root 3 x squared plus 100 minus 3x all squared sitting on pi, and that is as required. 26b. By considering the quadratic function in part A, show that the maximum value of a of x occurs when all the wire is used for the circle. In other words, there will be none for the triangle. Okay, so let's restate the area function which they gave us. A of x is a quarter outside of root 3x plus 100 minus 3x all squared on pi. Let's expand that out. So it's a quarter root 3x squared plus 1 on 4 pi in front of this when expanded is 100 squared minus 600x plus 9x squared. All right, let me pull out a 1 on 4 pi. So I'll introduce a pi here on the x squared plus all these terms. And now I can see that I can collect that 9 with the root 3 pi. So I have 1 on 4 pi. The coefficient of the x squared is root 3 pi plus 9 minus 600x plus 10,000. All right. This is a concave parabola, i.e. its vertex is a minimum. That's not useful to us because we're looking for the maximum. Therefore, the maximum must occur at one of the endpoints. Okay, now we know that 3x is trapped between 0 and 100. So x is trapped between 0 and 100 on 3. So we need to test what happens at x equals 0 and x equals 100 on 3. Okay, at x equals 0, a of 0, when substituted into the above, just gives us 10,000 on 4 pi, which is 795.77. At x equals 100 on 3, a of 100 on 3 equals 481.13, which is clearly not the max. Okay, so the max occurs at x equals 0, i.e. there is no material for the triangle. It is all used by the circle. And that's what we had to prove. Thanks for that. That's the end of part 8. Thanks for listening to Purple Mountain Maths.